PQRS is a quadrilateral labeled anticlockwise, and we're asked which of the following is a necessary but not sufficient condition for PQRS to be a parallelogram. So I'm just going to write PQRS to be a parallelogram on the right, and then think about what it means to be so necessary. So necessary means that parallelogram is going to imply the left-hand statement, but we don't want the right-hand statement to imply, sorry, the left-hand statement to imply the right-hand statement. That is what we're looking for here. Okay, so I think the first thing I'm going to do is look at the scenario right to left and see which ones are true. So if PQRS is a parallelogram, does it follow that PQ is equal to SR and PS is parallel to QR? Yes, it does. So I know that that is the case. Does it follow that PQ is equal to SR and PQ is parallel to SR? Yes, it does. Does it follow that they're all the same? No, it doesn't, because that would be a rhombus. Parallelogram is just two pairs of equal sides, but like a rectangle. So actually, we can immediately rule that one out. We could still look into the left, go into the right if we wanted. And does it follow that PR is equal to QS? No, it doesn't, because this diagonal will be longer than this diagonal. So immediately I can see it's between A and B. Now let's work our way through left to right. Okay, if I have A, then I just need PQ to equal SR and PS to be parallel to QR. So I might draw PS here and QR along the bottom. Now I could maybe create a parallelogram, but what if instead of it going like this, I could make it like that. I could make a trapezium. Then, yeah, this would be an isosceles trapezium. I've got PQ equal to SR. I've got PS parallel to QR, but it's not a parallelogram. So actually, I'm there just for that first one. A is going to be our answer. We're just going to carry on through though and check the others. So if PQ is equal to SR and PQ is parallel to SR, okay, so then I would have these two the same length and parallel. And then I've got no choice but to just join them up and they would be the same. So actually this is an if and only if relationship. If they were all equal, does that imply a parallelogram? Well, I could create a square, but that is actually an example of a parallelogram. Parallelogram is just two pairs of equal sides and two pairs of parallel sides. A square satisfies that, as does a rhombus. So in fact, that is a sufficient condition. Whereas PR equaling QS, that will not imply a parallelogram. You won't ever get that in a parallelogram. So this one is both it's not necessary or sufficient. So quite nice the different sets we have. We've got like all four represented: necessary, sufficient, necessary, not sufficient, etc. But we can see our answer is A. Well done.